All right, so in this lesson, we are going to solve a system of linear equations by using something called the elimination method. So we're going to find a common solution using elimination. So let's do it. Example 1. We have two equations, x minus y equals 11 and 2x plus y equals 19. Now, it's easier just to sort of like show you. So I'm going to write these two equations, x minus y equals 11, and below it, I'm going to write 2x plus y equals 19. Now I'm going to combine these two equations. So x plus 2x, negative y plus y, and 11 and 19. Now, the reason I do this is because if I combine these y's, negative y and plus y, it becomes 0y. So like plus 1y minus 1y is 0y. They have to be opposite. They can't be the same. Like it can't be plus y plus y. It can't be negative y, negative y. One has to be positive. One has to be negative. And then I just combine everything else too. So x plus 2x is 3x. And 11 and 19 give me 30. Now I can solve for x. Divided by 3, divided by 3. I get x equals 10. Now, I know what x is. X is 10. Let me see if I can make that 10 a little nicer. Okay, so x is 10. So if I know what x is, I can figure out what y is. So for instance, I'm going to substitute 10 in for x in the first equation. X minus y equals 11. And like I said, for x, I'm going to substitute in 10. You know what? I'm going to do this part in a different color just so it can stand out a little better. So we have x minus y equals 11. And we made x into 10. We substituted 10 for x. Minus y equals 11. Now I'm going to solve for y. So minus 10 minus 10. So I get negative y equals 11 minus 10 is 1. Now I need to divide by negative 1 to get rid of that negative 1. And y equals 1 divided by negative 1 is negative 1. Now I want you to remember that this, if I know x, then y will be negative 1. Y needs to be negative 1 for this equation and in this equation. So I'm going to show you that I would get the same answer when x is 10, like when I use this equation also. So let me show you that. 2x plus y equals 19. So for x, I will once again substitute in 10. So 2 times 10 plus y equals 19. 2 times 10 is 20. So 20 plus y equals 19. And if I subtract, well, once I subtract 20 from both sides, I get y equals, actually I'll put it a little up here, y equals 19 minus 20 is negative 1. So this is just to show you, actually let me write that a little better. This is just to show you that once you know what like x is, if you plug it in, if you substitute 10 in for x in this one or this one, you'll get the same answer. You should get the same answer because like it's a common solution. So if a negative 1 goes with 10 in this equation, the negative 1 goes with 10 in like this equation also. And don't forget our solution goes in the, well, we express it as an ordered pair. So the solution to this system of equations, is, remember x, so 10 comma negative 1. This means 10 negative 1 makes both equations true. Visually, like both lines of solutions will intersect at this point. Cool. Now, when we do the rest of these, you don't have to, once you know one, you don't have to plug it into both. Like, you don't have to substitute 10 in for both of these equations. Just do one of them, because once again, you should get the same answer. I mean, if you want to, you can do it in both, but you don't have to. So let's look at example number 2. Example number 2, our equations are 6x minus 5y equals negative 1 and 3x plus 2y equals negative 5. I'm going to stack these. 6x minus 5y equals negative 1 and 3x plus 2y equals negative 5. Now in this case, nothing like crosses out when I combine them, right? So I'm going to have to multiply here. So if I multiply by 2, I will get 6x, which gets me close, but I can't put 6x with 6x. I would get 12x. I need this one to become a negative 6x, or this one right here to become a positive 5y. So I am going to multiply this by negative 2. So negative 2 times 3x is negative 6x. Negative 2 times positive 2y is minus 4y. And negative 2 times negative 5 gives me positive 10. Now I'm going to bring this equation back down. So 6x minus 5y equals negative 1. Now, as you can see, I can eliminate something, because that's why it's called elimination. So negative 6x plus 6x gives me no x's. Negative 4y minus 5y gives me negative 9y. Negative 9y. And 10 and negative 1 give me positive 9. Divide by negative 9. And I get y equals, positive divided by negative is a negative 1. Cool. So I can substitute this negative 1 in for y in this equation or this equation. I don't know why. I sort of like this equation right here. So I'm going to use this first one. No, I want to use the second one. Well, I can't even remember. I'm going crazy here. I'm going to use this one. 3x plus 2y equals negative 5, because these are positives. 3x plus 2y equals negative 5. And for y, I'm going to substitute in negative 1. Okay, 3x plus 2 times negative 1 equals negative 5. A positive times a negative is a negative, so I'm going to write minus 1. 3x minus 1 equals negative 5. I will add 1. So 3x equals 1 minus 5 is negative 4. Wait, something happened. Oh, right here. I see what I did. 2 times negative 1 is negative 2. I don't know why I wrote negative 1. So that negative 2. There we go. So 3x minus 2 will give me negative 5. I will add 2. Add 2. So 3x equals 2 minus 5, or negative 5 plus 2 gives me negative 3. Divide by 3. And x equals negative divided by positive is a negative. 1. Let me just do one quick thing to make sure I didn't do anything wrong. So negative times positive is negative, negative times positive is negative, negative times negative is positive. Cross these out. Negative, negative, together makes a negative. Okay, positive times negative is a negative. Add 2, add 2. Okay, I guess my answer is -1, -1. I didn't think I meant to do that. There's a lot of negative ones going on. So -1, -1. All right, so let's look at one more. Example number 3 reads, well, the equations are 4x plus 2y equals -14 and 10x plus 7y equals -25. So if I try to, well, I like to stack them just to see them first. 4x plus 2y equals -14 and 10x plus 7y equals -25. All right, if you notice, it's hard to turn 4 into a -10. It's hard to turn 2 into a -7. Or like, it's hard to turn 10 into a -4 and 7 into -2, right? So we need to find a common multiple. 4 goes into 20 and 10 goes into 20. So I'm going to do that. So I'm going to multiply this by 5 and this equation by 2. The problem is, if I leave it like this, both of these will be positive, and then they won't go, like, they won't eliminate each other. It won't become 0x. So I'm going to make this one a -5. So -5 times 4x is -20x. -5 times positive 2y is -10y. And -5 times -14. So a negative times a negative is a positive. 5 times 10 is 50. 5 times 4 is 20. So that's 70. All right. 2 times 10x is 20x. That's good. That's going to cross out later. And 2 times positive 7y is positive 14y. So plus 14y. And positive 2 times a negative, so a positive times a negative is a negative. 2 times 25 is 50. Okay, so I combine these, they go away because they become 0x. -10y plus 14y, or 14y minus 10y is positive 4y. 70 minus 50 is 20, positive 20. Divide by 4. Y equals 5. Cool, we didn't get another -1. Okay, now I'm going to substitute this 5 in for y, and it doesn't matter which one. So I like this one. This one's a little smaller looking than this one. So 4x plus 2y equals -14. So 4x plus 2y equals -14. The y was 5. Well, I'll do it like this. So 4x plus 2 times 5 should equal, will equal -14. So that went there. And 2 times 5 is 10. So I get 4x plus, I'll write that a little higher, 4x plus 10 equals -14. I subtract 10 from both sides. I get 4x equals, that's -24. -14 minus 10 is -24. Divide by 4. Divide by 4. So a negative, x equals, negative divided by a positive is a negative. 24 divided by 4 is 6. Cool. Not another -1. All right. So my solution is -6 and then 5, right? -6, comma 5. And that is it. Thank you.